Okay, this is our double angle identity 4.5 section tutorial. And if you're looking at the section 4.5, we're going to be specifically looking at using the formulas for the double angle identity, or the identities for them. And there's 5 different double identity formulas. Cosine 2 theta has 3 different variations of the formula, mainly because of the Pythagorean identity. So if you're writing it in terms of theta, then it would just be cos squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cos squared theta minus 1. Sine 2 theta has one version of the double angle identity, and it's equal to 2 sine theta cos theta. And tangent has its own version, 2 tan theta over 1 minus tan squared theta. So as you notice, all the double angle identities are the theta is, the 2 theta is double of the theta that's in the identity formula. So you're always dealing with half of the angle in this part and double the angle over here. And remember, when you're dividing, you can't divide out here a 2 and get it normally divided out. If you want to divide out a 2, it has to be out in front of tangents. So what we're going to do is we're going to do a couple examples here. The first one I'm going to do is finding exact values, which is a common one that we do a lot of. And here's my first example. It says if we have sine theta, that's a single theta, is equal to 1/5, what is the exact value of 2 theta, sine 2 theta? Well, if we look at the formula for the identity of sine 2 theta on page 165, we know the identity is that sine 2 theta is going to equal 2 sine theta cos theta. And we'll notice that if we're looking at this, we already have the sine given, but we don't have the cos given. So we have to first calculate cos theta with Pythagorean theorem. Sine squared theta, or Pythagorean identity, pardon me, not theorem. Sine squared plus cos squared is equal to 1. Okay, so here we go. Let's find out. So we put in our 1/5 squared. And I guess I should have told you what quadrant is in. Let's say the third quadrant. Let's see. No, sine is not positive in the third quadrant. Let's say second quadrant. You always have to know the quadrant for sines. Just an oversight on my part. Say it's in the second quadrant. So we have 1/5, that's the sine, squared, plus cosine squared theta is equal to 1. So this is 1/25 plus cos squared theta is equal to 1. So bring this over. So cos squared theta is equal to 24/25 if we do it that way. Now we have to take the root to get that. So cos theta is equal to the root of 24/5. So we can say this is like root 24 over root 25, which is root 24/5. Just make sure that's still in the field of view. And if we want to reduce root 24, we can take out a perfect square of 4. So if we take 4 out of that, that gives you 2 root 6/5. Now that is not an exact value that's correct yet, because we have to check the sign. In the second quadrant, we know that sine is positive and everything else is negative. So since we're doing cosine, this is a negative value. So we're half done. We now know that cosine theta equals negative 2 root 6 over 5. So now we just plug in our values into the double angle identity formula. So I'm going to flip over here into my next page. So put that up here. Make sure that's still centered. Okay, there we are. So I'll plug in these numbers now. So our formula is that sine 2 theta is equal to twice sine theta times cos theta. So let's do that. Twice sine theta was 1/5 positive. Cos theta was our negative 2 root 6 over 5. So we have to be able to multiply all of these things together. So 2 times 1 is 2. 2 times negative 2 is negative 4 root 6 on top. And on the bottom, we have 25. Can we reduce the 4, negative 4 and 25? I don't think so. Can't take a common factor out. Can't. So this would be our exact value. And that's how you would do one of those. One more quick example here that you can use, since we have a few more minutes. Sometimes they'll use combinations of the 30, 60, 90 degree triangle. And they might ask you, find the exact value of, and they'll give you a version of the double angle identity. So it would look something like this. Let's say they might say, what is the exact value of, let's use a similar one that we just worked on. Let's say they had 2 sine 15 cos 15. Question mark. So you would recognize this as an exact a line in the double angle identity formula. So this would be, we could say this would be the same as sine 2 times 15 would be the same thing as saying 2 sine 15 cos 15. Therefore, this would be sine of 30 on this side. So we know that the sine of 30, if you look all the way back in your book, in the 30, 60, 90 degree triangles that we have, and if the one reference page that you can always look at is page 3 or 4, I believe. Let me look at it here. All of them are on page 4. We know that sine of 30 is 1/2. Let's make sure that's in our field of view for our last question. So again, just recognizing that as a double angle identity formula, recognizing that 15 would be the theta, so twice 15 would be actually 30 degrees, which is given to us in a special angle relationship. Okay, in our next tutorial for 4.5, we're going to do another exact value question, but we're going to do it for all 3 trig ratios.